All right, so we're going to do a little test review. So let's go through some questions. It could be that geometry stuff. It could be, and the problems, again, look just like the examples that we've done, and they look just like the homework problems. So if you want to go through some of these homework problems, maybe you don't have like one particular, but you see one, you're like, man, I really don't know how to do that. So that's what I want you to do. So let's start with R1. Let's go to the page where all the homeworks are. So you got your book? Let's everybody go to, let's see, page 16. So if you go to page 16, let's take a look at some of those homework problems. I'm going to take this off. I'm far enough away from you. So let's take a look at some of these. Probably, it looks like starting around maybe number 49 would be some of the first type of problems. So somebody give me a problem in there that you think could be on the tests. I mean, it's the stuff that I gave you homeworks on and had on the quiz as well. So do you see anything in here? 77? Okay. This is page 16, number 77. This looks like it's section R1. Well, Pythagorean Theorem, maybe. Yeah, Pythagorean Theorem. What other like kind of formula things do we need to know? We're not doing any of the factoring. All the rectangle, circle, all that stuff I'll give you. All right, so you don't have to know any of that. Really, I think Pythagorean Theorem is probably the only thing you need to know. No. And also there was, I don't even think I gave you problems on this, where you had to find the domain. You remember, I think we might have done that in class, right? In one of the lessons, did we talk about the domain? But I don't think I gave you problems on that. That's not going to be on the test, all right? So you don't have to worry about that. It's just working problems. That's all you got to do. So we said number 77. So let's take a look at that. So it's adding fractions, or in this case, subtracting, which is kind of the same thing. 7/18. All right, so what you want to do is you want to find, what do you do when you add or subtract fractions? What's the most important thing to do here? Find a common denominator. That's right, okay? So what in the world would the common denominator be for 30 and 18? You could just multiply them together if you wanted to, okay? But is 90? 30? Well, it's got to be at least as big as this right here. I don't even know, to tell you the truth, off the top of my head. But how do we find it? I can do this. I can take 30. Let's go off to the side here. I can take 30 and kind of do that little factor tree thing. All right, let's find all the prime factors. All right, so what do we got? We got 3 times 10. Whoops, what am I doing? 3 times 10, and then we have 2 times 5, right? All right, we're going to come back to that. Is anybody showing you how to find a least common multiple by doing it this way? I think I did once in here. What's 18? It's 9 times 2, right? And what's that? 3, 3, and 2. So here's what we do. What we do is we look to see which numbers basically show up here and show up here, okay? So let's start with the smallest one. There's a 2. If it shows up in both places, we use the number of times that it shows up the most number of times. I didn't say that very well. We use the number that shows up the most number of times. So I got 1, 2 here, and I have 1, 2 here. So it only shows up how many times? One time in each place. You follow me? So even though it shows up once here and once here, it's not twice. It only shows up 1 time here and 1 time here, so we just use one of them. I'll circle it. Okay, so we just use one of them. You could have circled this too if you wanted to. What other numbers show up? What's the next biggest number? A 3. There's a 3 here, but there's 2 3s here. So which one do we use? We use the one that shows up the most number of times. So we use these right here. So you have 1 3 here, and you got 2 3s over here. So you always use the one that shows up the most number of times. So we use this one right here. What other number shows up? And it doesn't have to be in both places. It just has to show up somewhere in here or in here. A 5. There's no 5 here, but there is a 5 here. There's just 1, so we circle that. Now, what do you think we do with all those numbers that are circled? What's that? We just multiply them together, and that's our common denominator. That's our least common multiple, or in this case, our common denominator. Okay? So, let's do this. 2 times 5 is 10, and this is 9, and our answer is 90. Okay? Not our answer, but our common denominator is 90. All right? So that's how you can find a common denominator. It took a little long by me explaining it, but for you to do it, it's very, very quick and simple, I think. So that's how you find a common denominator with big old numbers like this. You could just sit there and guess and figure out, but 18, I don't really know off the top of my head, like how many times or if 18, goes into 90 or not. But this way, it's a surefire method, works every time. All right, let's do this. What did we changed this from a 30 to a 90. So what did we multiply 30 by in order to get 90? A 3. So watch. I multiplied this by 3. So what are we going to have to do to this? I'm sorry, this up here. Multiply that by a 3. It's not the rule that says whatever you do to one side, you got to do to another side. Remember that from Algebra 1? It's basically, what's 3 over 3? It's just a 1, isn't it? All right. Can I multiply anything by 1 and not change the value of it? Yeah, absolutely. Okay, anything times 1 is what it originally was. So sure, I can do that. So what do I get now when I get 1 times 3 up here? I get a 3 over 90. So 3 over 90 is the same as 1 over 30. Would you agree? Sure. And we're doing this because the only way we can add or subtract fractions is if we find a common denominator. And that's what we have to do right here. So what about this? 18 times what is 90? I think it's 5, isn't it? Yeah. So we multiply that by 5 to get 90. I meant that to be yellow. That's okay. So what do we do to the top as well? Multiply that by 5. Because really, what are we doing? We're just taking that 7/18 and multiplying it by what? A 1. No, we're multiplying it by 1 because 5 over 5 is a 1. Are we allowed to do that? Yeah, absolutely. So now 18 times 5 is 90, which you already determined. And now right up here, 7 times 5 is what? 35. So 3 over 30 is the same, 3 over 90 is the same as 1 over 30. 35 over 90 is the same as 7 over 18. All right, so it's the same numbers. We just write it with a common denominator. And now what do we do at the top here? Keep the denominator the same. And what do we do at the top? We subtract. So 3 minus 35 is negative 33. Do we just circle it and leave it? No. What do we have to do with this? We've got to simplify it, reduce it. What goes into both of these things right here? It's pretty easy. 3 does. So 3 goes into 33 11 times. 3 goes into 90 how many times? 30 times. Everybody with me on that? So our answer now is negative 11 over 30. It doesn't simplify any more than that, and that's our answer. So that's how you subtract or add fractions. We good with that? Let's pick another one. Let's pick something where you have to do like order of operations, like 57, 8, 9, 60, 61, 62. Any of those. Which one of those? We'll do one of those. Pick one. Which one? 57. Okay. So let's do 57. If I could read, between it being dark and my glasses needing an upgrade. Is that a bracket? Yeah. And it's 3 times 5. And then plus 2. They put a dot there, but did they really need a dot? 3 minus. I don't know why they'd put a dot in between that parentheses and that 2, but they do. And then you got a bracket. All right, let's go through this. Do you remember what it is? Please what? Oops, I put the M. I got ahead of myself. Please excuse what? My dear Aunt Sally. Or some people say PEMDAS or something like that. I don't know. I always said, please excuse my dear Aunt Sally. It's just as easy to remember. So what's the first thing we do? We do anything that's in parentheses first. Now remember, the bracket is the same thing as a parentheses. This is just a parentheses inside a bracket. So what about this? 3 minus 2. That's just a 1. Instead of writing it down, I know you can't do this, but I'm going to put a 1 there. All right? And then So now we've done everything in the parentheses. Now we got to do all the stuff in the bracket. So what do we do first? Do I go 5 plus 2? No. What do I have to do first? I got to do multiplication first, don't I? All right, so that's going to stay. That's going to stay. We'll put the bracket here. Let's do the multiplication. So those are being multiplied, so let's multiply them together. That's 15. This is being multiplied, the 2 times the 1, and that's just a 2. With me? All right. Technically, you should put equal signs here. 6 minus. Now, if you don't want to use the bracket, you don't have to. Remember, it's the same thing as a parentheses. But what's 15 plus 2? 17. Okay, so we did inside that little parentheses right there. It's addition, but we did what's inside the parentheses or the bracket. And now we just do this. So what is that? Negative 11. That's it. That's all there is to it. So if this problem was on the test, I want to see these steps. All right, this is definitely, some of you guys could possibly do this in your head. All right, but I don't want you to do it in your head. I want you to show me how you got the answer. You with me? There may be some problems where you can just do it in your head and write it down. Okay, I get that. But if you can show steps, show your steps, circle your answer, and then you're good to go. So if you get that right, what do I put next to it? A check mark. Okay, so that means you would get it right. All right. Enough of those. Let's do one where you divide the fractions, like 81 or 82. Does it matter which one we do? Let's do 81. Basically both the same. 5 over 18 over 11 over 27. It seemed like a lot of people got confused on this during the quiz when we had this. So let's do this. Basically, what is this line right here? It's division, isn't it? So you have a fraction divided by another fraction. You remember the old school symbol for division? Put a little line, a little dot here and here. Yeah. So that's basically what this is. Okay, it is division. Put in equals. So what do we do when we divide fractions? We don't really divide fractions. We always turn it into something. We turn it into a multiplication problem. So division is the same thing as multiplying by the, give me a word. Yeah, we could say inverse. What's another word? That starts with an R. Reciprocal, okay? It's kind of the same thing, but inverse can be used for some other things, so I like to say reciprocal. What does that mean? What does the reciprocal mean? You just flip it. That's right. You just flip this fraction. So instead of 11 over 27, we're going to multiply by 27 over 11. That's the same thing as division. So I turn a division problem, excuse me, into a multiplication problem. We good? So what do? Do we just multiply straight across? Well, sometimes, but yeah, let's try to simplify. Does anything divide out? Okay, I got an 18 and I got a 5. Nothing is in common with that. Nothing's in common with an 11 or a 5 or a 27. What about 18 and 27 though? Yeah, what goes into both of those? A 9 does, right? So 9 goes into 18 how many times? Twice. And 9 divides, when I say go into, that's kind of like a shorthand way of saying it divides into, okay? So what divides, or 27 divided by 9 as well is what? 3. Does anything else cancel out? Does 2 go into anything up here? Does 11 divide into anything? Nope. So what do? We just multiply straight across, which is 15 over 22, and that would be our answer. Make sure you simplify. All right, you always need to simplify when I give you something like this. Don't leave your answer, whatever 5 times 27 is, over 18 times 11. Don't leave it like that. Make sure you simplify and give me the most simple answer that you can get. We good? All right. Well, test is easy so far, isn't it? Yeah. So you should get those. Now, I did, for a lot of these beginning ones, I gave you like a couple problems of each style, right? Mixed them up a little bit, but give like 2 problems from one kind of problem, 2 from another one, 2 from another one, like that. So make sure that you know how to do them, because if you don't know how to do them at all, you're probably going to miss 2 problems instead of just 1. Yes. 91. There will be not factoring, but multiplying through parentheses. I don't think I give you one with a fraction like that. But I do give you something like 90. Let's do like 90 and 94. How's that? So 90, unless you guys have a particular one you want to ask, but they're all kind of the same. All right, I'll give you something that looks like this. And what do they say? Use distributive property. I probably won't tell you to use distributive property. I forget what I tell you on there. I guess I could look. I got it right here. What did I say on this? It says evaluate each expression. Okay, so it says evaluate this. Well, what does that mean? It means do what it tells you to do. What's it telling you to do? It's telling you to multiply that 4x by everything in that parentheses. That's what it's telling you to do. So the problem will say evaluate. All right, so let's do it. 4x times x. What's x times x? X squared. Very good. And then you put the plus sign right here, and then you go 4x times 3. It's just distributive property. I won't use the word distributive property on the test. I'll just say evaluate this expression. You have to know that you're using distributive property on this. And then you multiply these two together. So 4 times 3 is 12. And then you just stick the x right there, and that's it. Is there any work to show on this one? No, there's no work to show on this. You just do it. All right? You just write it out and do it. What I would suggest, you don't have to do this, but I would suggest that you put all this stuff in that little answer block right that I give you, so you can see the problem. A lot of people will take the test and then they'll look at it and just start doing the problem from looking at the test. My suggestion, you don't have to do this, but my suggestion is you write down the problem if possible. If it's not like crazy long, because I think it'll make it so you won't have as many mistakes. All right, that was an easy one. Let's do one where you have to do FOIL method. I said 94, but you can pick any of them. Does it matter which one? Actually, let's not do 94. They're both plus. That's too easy. Let's do one where both negatives. How's that sound? 97? 97, they're both negative. So it's x minus 8, and it's x minus 2. All right, so again, it says just evaluate this expression. It just means you multiply these together. So let's do that. On this one, this is still distributive property, but it's a little bit more specific. It's kind of like that, I just said it a second ago. What is it? A FOIL method. Okay, it's the FOIL method. So first, outside, inside, last. So let's do that. So you multiply the first two together. So x times x is x squared. And then you do the outside. So remember, look at the sign in front of it. It's a negative 2 times x, which is negative 2x. That's the part where if people are going to mess this up, that's where you're going to mess it up. And then the inside term. So it's negative 8 times x, which again is minus or negative 8x. So put a minus sign there. And then you got your last terms. It's negative 8 times negative 2. What's negative times negative? It's positive, and then 16. Do we circle it and leave it like that? Nope. We have to finish simplifying it. So negative 2x minus 8x, it's negative 10x. You need to know how to add and subtract. Negative 2 minus 8. Remember I taught you this? You add the opposite. That's how I always say it. Some teachers say it different, but that's how I say it. And so it's adding, and they're the same sign, so you just add them up, you keep the sign. So it's negative 10x plus 16. And then that's it. You're done. All right, so on this one, yeah, I would want to see this. You could probably do this in your head. All right, a lot of you could. All right, but I would write it down. Okay, it saves you from making careless mistakes inside your head. Right, if you do too much, inside your head, then you have a tendency to make mistakes. Write it down, then you can look at it. You can go back when you finish your test. If you got a few minutes left over, you can look at it and make sure that you do all that correctly. All right. Well, that should be good. That's, what was that? Was that R1? Yep, so that was basically R1. Yeah, I don't see anything else on there. So let's skip over to R2. Let's see where R2 starts, like the homework. Oops, I skipped way ahead. There we go. Looks like on page 27. All right, so that was our next homework. So that was R1. This is R2 on page 27. let's go through and see what I'm going to give you. I'm going to give you a couple graphing problems. All right, we had that on the quiz, right? So that was nothing different. And we went over this when we went over the quiz. So I'm going to ask you to graph something. On the number line, yep. So it's 29 to 32. Any of those? Which one of those? I'll do one. First one to tell me. 29 to 32. Which one of those do you want to do? Somebody give me one. 30? Okay, let's do 30. So it's x is less than 4. X is less than 4. So I give you a number line like this. Well, actually, I don't give you the number line. You're going to have to draw your own number line. I did on the quiz, though, didn't I? I gave you a number line on the quiz. So you're going to have to draw your own. Put an arrow here and an arrow here. It says less than 4. So I'm going to put a few. You don't have to put like 20 of them on here. Just put a few. I'm going to put a 5 here, a 4, a 3, a 2, a 1. Why did I go that way? Because I'm going what? I'm going less than. All right. So I put the 4 up here. So it says less than. It doesn't say less than or equal to. So if it's just less than, what kind of a dot do we put here? An open circle, right? Remember that? Because it does not include 4. It's everything's just less than 4. So we do not include 4, so we put an open circle, which does not include the number 4. And look what direction this arrow is going. Look which direction it's pointing. See it? It's pointing to the left. So which way is our arrow going to go? It's going to go to the left, all right? Less than is to the left. So you just kind of darken it in. Could have done this in a different color, but you darken it in, make a darker arrow. Some people do this. They'll put a line up here like that. I'll accept that. A lot of teachers teach it that way. I usually teach it just darken in the arrow like this, okay? Either way would be fine. You don't have to have both of these, just either way. And that's it. Well, my goodness, the graphing's simple, isn't it? Isn't that easy? Yeah, I think so. I think you do too. Let's do this. Let's see what else is next. All right, another thing that says evaluate. Do you see the problems like 39 to 46? I'll give you something like that. All right, I'll tell you what x and y are equal to, and you just basically just plug it in. Okay, plug and chug. That's what my professor in college said, plug and chug. So I've been saying that for 30 years now when I teach math. So which one of those do you want to do? There could possibly be one. Yeah, there is one. 45? Okay, let's do that one. Oops, there it goes again. I pushed that button on that dumb pen. Okay, 45. Let's do number 45. So it's 3x plus 2y. I'll tell you what x and y are equal to in just a second. We had this on the quiz, right? Something like this. I don't know. Might have had this exact one. Can't remember. Was it the exact one? X is equal to what? -2, and y is equal to +3. All right, so what we're doing is just going to take what x is equal to and stick it in wherever you see an x. We're going to take what y is equal to, which is 3. We're going to stick it in wherever we see a y. And then you're just going to do the math, okay? Just figure out what this is equal to. So here's how I would do it. It's 3x, or 3 times x. So I'm going to put a parentheses there. And what do I put in for x? -2, right? Plug and chug. Then you put a plus sign, and it's 2 times y. So put a 2 in a parentheses and figure out what y is. Y is 3. So you stick in a 3 right there. Over. Let's do the bottom. It's 2 plus y. So 2 plus, and y is 3. So I put a 5 or a 3 right there, and that'll be 5 in a minute. Plug and chug. That's what we just did. Okay, we plugged. That was plugging it in. Now we chug. All right. Now we actually work this thing out. So let's do the multiplication first. So that's going to give you -6. This is going to give you what? +6, right? It's a plus 6. And this is over what? 2 plus 3, which is 5. One more step. Well, kind of. -6 plus 6, what in the world's that? It's 0 over 5. What's 0 divided by 5? It's 0. 0 divided by anything is 0. All right? And so that's our answer. Showed my work, did my steps, got my answer, circled it. That's what you should do on the test. Everybody got that? All right, if you don't get that, go back to the YouTube and watch it. Yes, ma'am.
I don't think this is on the
Okay.
but it's a chapter review, and it's sometimes different.
Do you have a page number? 82? Oh, okay. So you went to the end of the chapter and just looked back on the... Okay, 82, number what? 26. Okay, we can do that. All right, so this is on page 82. Oops. Come on. 82, number 26. And it's one of those evaluate problems again. They tell you x is -5 and y is, what is it? 7, +7. And then here's what you're evaluating. 2x to the second, y to the -2nd. All right. You don't necessarily have to do what I'm going to do right here, but I would. Okay, if I were you, I would do this. Before you start plugging these numbers in, what do you think the big issue with this problem is going to be? It's that negative exponent. Okay, the squared, I'm okay with squaring stuff. That's not that big of a deal. It's that negative exponent. All right, so let's do this. Let's make it a little easier for ourselves and make it a positive exponent. So how do we do that? So we're going to take this and do what to it? Remember? You guys are scaring me. Yeah, flip it down to the bottom, okay? So you flip it down to the bottom and make it y to the +2nd. We're actually going to have some problems where you actually just have to do that. Remember on the quiz, you had to make it so all the exponents were positive? All right, we will have something like that. But on this one, it just makes it a little easier. So I'll go through the rest of this really quick. So it's 2 times x squared. So x is -5. This is another place where you could mess up, forgetting to put the negative in for this. Actually, it really wouldn't make any difference on this particular one. And then y squared, so that's 7 squared. So we work this out. Do the exponents first. Remember, please excuse my dear Aunt Sally, the excuse, the e, that's the exponents, so you do that before you do any multiplication. It's -5 squared, so it's -5 times -5. What does that give you? It's +25. A lot of people put negative because they see that negative and they just think it's going to be negative because they see that negative. But you're squaring it. When you square a negative times itself is a positive. And this is over 49. Let's finish this up. 2 times 25 is 50 over 49. And just leave it like that. You don't have to change it to a mixed number. Does that help? All right. What else? We only got like 5 minutes left. So if you want to skip to the geometry or you want to go to the R.4, you could do that. It's up to you. So give me a page number, give me a number. Page something, number something. So give it to me. Go ahead, Josh. Anybody else find one while Josh is looking? Here's your chance. Yeah. Page what? Oh, back on page 83. Would you say 100? No, not like that. No, we're not going to have this. No, if you didn't see it when we did the examples in class, it's not going to be on the test. All right, Peyton? 50? 50? Okay. I don't put any long division on there. There's no long division, okay, because that's what a long division problem. So I didn't put any long division stuff on there. I knew that was going to cause people problems, and we didn't really do it a whole lot, so I'm not going to put a long division problem on there. There's no long division. Like, give me a problem. I don't know. And I don't give you any square roots. There's quite a few things on there that I don't. What'd you say, 45? On page 82? Oh. Like page 82? Or page 49. Okay, page 49. No, those are all division problems. I mean, you might have a thing where it's square, like a parentheses and squared. Do you see that? 81 to 88. Do you see those problems? Yeah, you'll have something like that on there. So pick one of those, and I'll do one. 86. Okay, what's that? X plus 1 cubed? Is that what it says? Yep. All right. So this is not this. I'm running out of time, so I just got to do the problem. So x plus 1 cubed. All right. What's happening when you cube something? You multiply it by itself how many times? 3 times. So watch. I may not be able to finish this, but let's see. This is what you have to do. So what I would do is this. I would do this first. Don't do them all 3 at the same time. That'll be way too confusing. So what I'm going to do is multiply this. I'm going to do it quick because time's running out. It'd be x squared plus 1x gives us plus 2x. Plus 1 times 1 is 1. So that's what those two would multiply together would be. That's just FOIL method. We've already done a FOIL method problem. Now we distribute. You take the x and you distribute. So let's do this quickly. It's x times x squared, which is x cubed, plus x times 2x, which is 2x squared. Let me finish this up. Plus x, and then multiply the 1 through here. So that's just an x squared plus 2x plus 1. Simplify, so that's x cubed. I got a 2x squared plus a 1x squared, and that's going to give me 3x squared. I got a 1x plus a 2x, which is going to give me a 3x. I'm done with that. And then plus 1. That would be your answer. Okay? All right. Make sure you go through those problems tonight, right? Pick some odd problems, practice them so you know what your answers are, and test tomorrow.